everyone, my name is Shivanthy Jones and today we'll be going over visualizing hypothesis testing. The overall theme for this presentation is accepting or rejecting the null hypothesis using visuals. The agenda for today, we will begin by talking about developing a hypothesis, the null and the alternate hypothesis testing, the four types of visualization hypothesis testing that we cover in this presentation, and end with a brief summary of my takeaways from this presentation and finally open the floor up for questions. A hypothesis is a tentative yet testable statement which predicts what you expect to find in your empirical data. Formulating such testable statements is called hypothesis development. Next, we look at null hypothesis and alternate hypothesis. A null hypothesis is set up to be rejected in order to support an alternate hypothesis. The null hypothesis expresses no relationship between variables, so it's basically set up to provide credibility to the study. The opposite of a null hypothesis is the alternate hypothesis. This is written to express a relationship between two variables. A null hypothesis is held true until statistical evidence can be provided to reject the null hypothesis. We now move on into the first of our four visualizations. The first visualization is testing for a mean. Along the y-axis, you have the probability of the defect, and then along the x-axis, you have the number of defects out of 100. The research question here is, on average, are the widgets from Acme Widget Company defect-free? So when we set up the null hypothesis, we set it up as that the average number of defects per 100 widgets is equals to 0. And the alternate hypothesis would be the average number of defective widgets per 100 widgets is greater than 0. When we look at the bell curve here, it looks like the probability of 0 defects is around 40%. So 40% of the time that we're producing these 100 widgets, we are going to have 0 defects. And then you notice that it starts to taper off when we look at the number of defects. So for one defect per 100, we're looking at about 25% probability down to a 0% for 4 defects. Based on the information provided, it looks like there is a probability that we do have defects per 100 widgets. Therefore, we would have to reject the null hypothesis in this case. The second visualization has two bell curves which we're comparing to two groups. The Major League home run hitting team is represented by the blue bell curve, and the minor league home run hitting team is represented by the red bell curve. Along the y-axis, we have the number of home runs, and along the x-axis, we have the fraction of the team that are home run hitters. The research question is set up as, does the average major league team have more home run hitters than its corresponding minor league team? So when we set up the null hypothesis, we set it up as the major league home run hitters per team equals the minor league home run hitters per team. And in this case, we assume that there is no difference in the number of home runs for the major league teams and their minor league counterpart. The alternative hypothesis is that major league teams will have more home run hitters than their minor league counterpart. So when we look at the visualization, the two bell curves over here, you could clearly see that the major league teams have more home run hitters than the minor league teams. When we look at the fraction of the team that are home run hitters, it looks like somewhere between 35 to 40% of the major league teams have about 16 home run hitters, and only 25 to 30% of minor league teams have 15 home run hitters. They look like they have about equal number of home run hitters between 30 and 35. That is kind of shown by the shaded area right there. So in this case, I would say we could reject the null hypothesis because there is a difference in home run hitters on average between the two teams. So for the third visualization, we are looking at an efficiency comparison. For that, we have a single queue with blue servers versus the single queue with multiple red servers. We have two bell curves, and the number of hours served per hour along the x-axis, and the number of hours observed is along the y-axis. The research question is, the efficiency curves of the red and blue teams were recorded. Do the teams have equal mean efficiencies? So when we set up the null hypothesis, we can set it up as there is no difference in efficiencies between the red team and the blue team. And the alternative hypothesis would be there is a difference in efficiencies between the red team and the blue team. So when we are looking at our bell curves, the first thing we notice is that they were not observed for the same amount of time. But if you look at the red team, they served about 30 customers per hour over 10 hours. That brings the total up to about 300 served. When we look at the same thing for the blue curve, they have about 50 customers per hour over a 4-hour period. That would bring it to about 200 total served. If we average that over 10 hours, it clearly looks like the blue team was a lot more efficient than the red team. So in this case, we would reject the null hypothesis as there is a difference in efficiency between the red and blue servers. Our last visualization is a correlational test. A German study tested how large industrial use vans utilized gasoline by correlating miles per gallon versus the weight of the van in this study. However, in this case, they forgot to state their hypothesis test after they found a significant correlation. So when we write the null hypothesis, it could be written as there is no correlation between miles per gallon and the van weight. The alternative hypothesis can be written as there is a correlation between the miles per gallon and the weight of the van. This visualization shows that as the weight of the van increases, the miles per gallon does decrease, so there is a negative correlation. The study has already established that there was a significant correlation. Therefore, we can reject the null hypothesis in this case as well. So my key takeaways from this presentation is the importance of creating a clearly defined hypothesis. A hypothesis must be testable to add credibility to the study. A null hypothesis is set up to be rejected to support the alternate hypothesis. A null hypothesis is held true until it is proven wrong by the statistical evidence. So what are the benefits of using visualizations? By using visualizations, you are able to make some quick decisions instead of having to do the math surrounding it. And it also makes it a lot easier to explain our findings to management through visuals than trying to explain it through words. Thank you all for watching my presentation. And now I would like to open the floor up for any questions that you may have.